Hello students, in this PowerPoint presentation we are going to discuss various triggering methods of silicon control rectifier. So in this we detail about what is the resistance triggering, what is the resistance capacitance triggering, and what is the EV junction transistor triggering. So we are all going discussing various triggering methods of SCR. So why we require triggering means in order to turn on the SCR we have to give the gate pass to SCR. For this, we are using various triggering methods. So in detail, we are going to study each triggering methods. That is R triggering, RC triggering, UJT triggering. Coming to R triggering, this is the resistance triggering. This is the circuit diagram. So here we have R1 resistor, which represents the current to gate of the SCR. R2 is a variable resistance added to the circuit achieved to control the triggering of SCR. Resistor R is a stabilizing resistor. Diode is required to ensure that no negative voltage reaches the gate of the SCR. So coming to the design, when R2 is 0, we need to ensure that Vm by R1 less than IGM, where IGM is the maximum or peak gate current of SCR. The condition to be satisfied R1 less than Vm by Ig. Also, with R2 0, need to ensure the voltage drop across the R does not exist of VGM value. VGM equal greater than or equal Vm by Rm plus R. So R1 is the gate limiting current resistance, R2 is used to where the gate current ends. Also finding Ig maximum equal V by R1, R less than Vg max by R1 by Vm minus Vg max. So diode D prevents the buildup of negative voltage at the gate terminal. So when VGP is less than VGT, therefore current I flowing through gate to SCR is very small, SCR will turn on, therefore load voltage is zero. When VGP is VGT equal, when the R2 set to optimum value, we see SCR is triggered at 90 degrees. So when VRG is greater than this value, so it is going to start the conduction. Therefore, alpha is equal sin inverse VGT by VGP. VGP is equal Vm by R, R1 plus R2 plus R. Alpha is equal sin inverse VGT, sum of R resistance by Vm into R. VGT and R1 R are the constants values. So resistor triggering is a simple circuit. It is advantage of this. Disadvantage is performance depends upon the temperature and SCR characteristics. Minimum phase angle typically to 4 degrees, not to 0 degrees. Maximum phase angle only 90 degrees. So these are the waveforms to be observed. So alpha is the firing angle. There is a triggering will be start. Coming to RC triggering circuit, in this additionally one capacitor is added at the low variable resistor. So capacitor charges during the negative half cycle through SCR turned on capacitor suddenly discharged through D2. So D1 projects SCR during negative second. The condition to be R is less than Vg minus Vg min minus Vd by R. So resistant capacity, this is a waveform we are observing. This is a trigger point, that is the output waveform, and it is compared with input waveform. Voltage crosses zero as the supply becomes positive. The capacitor charges through resistor. So R from initial voltage of minus Vm to a positive value. The capacitor voltage equal to gate trigger voltage SCR. The SCR is going to 5. So this is the resistance capacitor for low I value of R. This is a waveform. So for low value of R, this is a waveform. So in this we are getting triangular triggering. In this we are maximum sinusoidal triggering. We are going to get Vm is the maximum voltage, Vt is the thyristor voltage. So by this triggering, capacitor charges during the negative half cycle when SCR terminals, capacitor suddenly discharge through T2. So advantages are triggering, it controls up to 180 degrees RC condition less than 130, greater than 1.3 by 2. To ensure minimum gate current R less than Vs minus Vg min by minus Vd 1 by 2. So this is the RC triggering waveform. So here at the T, we are applying different triggerings at different firing angles. The condition to be satisfied as RC is greater than or equal to 1.3 T by 2. This is the circuit diagram of RC triggering. So in case where R is large value, the capacitor charges from minus Vm to Vm. When R is small, the VL is more. When SCR triggers, the voltage of across the 1 to 1 volts. This turn on lowest. Coming to design equation, the condition R less than minus Vs minus VGR minus VDM by Rm is to be satisfied to trigger the SCR. Coming to unijunction trigger list, it is in this n-type silicon bar which p-type bar emitter is embedded. It has three terminals, base 1, base 2 emitter. So between B1 by D is big like arterial resistance. So RBB is equal to RB1 plus RBT. Usually the PGN region is heavily doped line indigenously lightly doped. The condition to be satisfied is VAB1 equal to VBB into R1 by RB1 plus RB2. So equal to neta VBT, neta value is RB1 by RB1 plus RB2. So this is the triggering how will happen. This is a circuit n equal neta equal RB1 by RBBO. So UGT exists some negative resistive properties which is shown in this region. So this is a peak point. So up to peak point to valley point, the UGT exhibits negative resistive properties. After that, there is a cutoff region which it is acts amplifier. In saturation region, it acts as a closed switch. So when maybe we apply between emitter with base reference to emitter voltage, the value of voltage required to turn on the UJT. The peak point at the which peak current flows to peak voltage. After that peak current increases but voltage across it drops. So the negative resistance UJT between peak point and after the valley point, the device acts as a normal diode. So this is how the capacitor will be charged. So the time constant of capacitor is given by T1 equal to RC, and next in the second wave there is no charging. After that Mali again capacitor charging. So it shows some triangular waveform. So that's why it is acts as a relaxation oscillator. So coming to reflection part, you have to know the what circuit diagrams is triggering or triggering or C triggering and UJT triggering, how the circuit diagram will be displayed. So what is the terminals to be varied for in order to triggering the gate pulse of SCR, you have to understood. Coming to reflection part 2. So you need to observe the waveform at each case. For R trigger, we get some waveforms. It get 90 conduction, 90 degrees conduction. For RC triggering, we are getting 180 conduction. For UJT, we are getting only 150 degrees conduction. So you need to observe the each and every waveform in the cathode ray oscilloscope. So after coming to lecture level practice questions, so design and analyze the R firing circuit, design and analyze the RC firing circuit. So understanding the UJT firing circuit. These three concepts are very important in the triggering methods of SCR. Thank you.